So I'm Zarino. I'm technically a designer, but also a developer working for a charity called My Society. My Society runs websites that you might know, like Fix My Street, which lets you report potholes to the council, and They Work For You, which lets you see what's happening in Parliament, which is particularly interesting at the moment. As part of that job at My Society, all the developers and designers all use Git basically every single day. And so when somebody asked for some help explaining Git, I thought, why not? I could explain that. So out of interest, show of hands as to who's used Git before. Okay, cool. Some people haven't. Amazing. How many people here do stuff that involves writing text or writing code all day? or not all day, but you have done. Okay. So basically, Git is a version control system. Version control is this idea of tracking changes to files. That's all it is. It's nothing special. So Git actually, if it helps visualize what's happening in Git, is that it's literally tracking changes to lines of code in files. In fact, I could probably just show you an example of, if I go to Fix My Street, say. So this is one of our products. And let's have a look at a recent commit. There we go, 2 hours ago, we had this commit, and all it's done, perfect example, all it's done is added one line of code. So there's a little plus, and that's the change. That was the commit. So it can get a lot more complex than that. You could have lots and lots of changes all happening at the same time. You could have thousands of people all making changes at the same time to different bits of the same project. But Git tries to make that simple. And it's useful for people in this room because it's, even if you don't collaborate on code with other people, it's useful personally just to track your own changes, to be able to revert changes, go back to previous states of code without having to literally create a copy of your code, backing up your code. It's also useful for going back and seeing oh, I made some change 3 years ago and I can't remember why I did that, or searching past work to find why you did stuff. And it's useful for sharing the code and combining it with code that other people have written. Git is just one example of a version control system. There are lots of others. Way back when I first came to Liverpool years ago, I used to be using a thing called Mercurial, which some people might have heard of. Before that, Subversion was fairly popular, especially in Mac users for some bizarre reason. So there's lots of others. And I tend to use Git at the command line. You don't have to use Git at the command line if you don't want to. There's loads of point-and-click visual editors for Git. I mentioned a couple there, like Tower and SourceTree, and GitHub Desktop as well. So GitHub has its own desktop client. And they make it easier to see stuff in a visual way, have lots of representations, but they're kind of the same as what you're writing at the command line. Another thing that people sometimes get confused about, because they come to Git through GitHub. Git is not GitHub. You can use Git without using GitHub. GitHub is just a way for people to share their code. It's a free website owned by Microsoft now. And you use Git to push your code to GitHub and share it with other people. GitHub's popular because it's got a couple of features that people like. So they've got an issue tracker, which is really useful, and you can even use the issue trackers for things that are totally unrelated to software or to Git, as we do here. It does. So we use a GitHub issue tracker for tracking things that need fixing in the space. But most people would use it for reporting issues with code and then being able to discuss what's wrong with a piece of code and see, and it ties in with the changes that are made to the code so you can see when things are being fixed. They've got this idea of pull requests. Pull requests is a way of suggesting changes to a code base that isn't yours, or sometimes it is yours. So you can also, it links in with this idea of forking. There's loads of jargon in Git, so stop me if I mention something that you don't recognize or need an explanation of, but Forking is basically making a copy of somebody else's code, their own project in Git is called a repo or repository. So forking a repository makes your own copy of it, and then you can make a change, improve something, fix a bug, and then submit a pull request to the original owner of the main version of that code and say, you should accept this. It fixes this thing, and here's proof that it works. You could, if you wanted to, you could use GitHub when you're pushing your code to GitHub. GitHub is just one remote. You could have lots of remotes. So at My Society, we've got our own private Git server running that we push all our code to, and then it pushes the code to GitHub. That way, when GitHub's down, which happens every now and then, work doesn't grind to a halt. We've got our own remote that we're pushing all the code to, and then eventually when GitHub comes back up, we synchronize the changes back. The whole point of Git is that you can have multiple remotes and they can all synchronize with each other. It's decentralized by definition, so that's the whole point. You could even set up your own Git remote on your own website. I've got one on my server, and I deploy my website using Git. Yeah, number 3. And you can even, I think, set up remotes that are literally on your own file system, so they don't even use the internet at all. So I think you can set up remotes to actual file paths, so you could push between repositories on a single disk. Why you'd want to do that, I don't know, but you could do that. Most of the time, you'll be doing it over SSH. People know what SSH is, so communicating with servers, logging into servers. That's how it works. If you wanted to start a Git repo in 5 commands, you could do it like so. In fact, based on what Jackie just said, I feel like I should probably create a Git repo. So let's, okay, so I'm in a folder somewhere on my computer. Let's make a repo for this talk, which is Intro to Git. So there's a folder. All of this Linuxy stuff, I assume you all know because you're all here at LivLUG, so brilliant. Let's head into that and Git init inside that. So it's created a Git repository. If I, not Git ls, ls minus la. So in here, all there is this folder called .git, and if I show you what's inside there, there's loads of stuff that you don't need to know about. But this is basically, if I wanted to stop this folder being a Git repo, I could just delete that .git file, and that's it.
So what does that repo command do at the top?
That's a shortcut I've set up that goes to the directory repos.
Oh, so it doesn't actually do
it's nothing to do with Git, don't worry. So now I've got a Git repo, I can do things like git status. So it tells me I'm on branch master, which I'll explain later. There's no commits, and there's nothing to commit because it's an empty directory. Let's copy in the notes that I'm speaking from. So these notes, currently on my desktop, I could move them in here. So in fact, I'll copy them for now. Twiddles, desktop, intro to Git. There we go. So now there's this file in there. So now we've got a new file we can see. And if I, can you see that at the bottom? It's really low down, isn't it? I could git status, and it will show me what's in there. Okay, cool. So I've created this repo. What's the next step? Step number 2 out of my 5 steps is to add it. So I could, it says it's untracked at the moment. It doesn't know what this file is. I'll cover untracked later. I could add that. For now, I will add it by saying which file I want to add. So there we go. And now if I did git status again, it's telling me slightly different now. So this change is to be committed, and I'll explain what that means later.
When you add a file, does it already have to be in the right place, or does it copy to the repo for you?
It's already in the repo.
At the moment it is, but if you click put add it, but you passed it a path somewhere.
No, you can only, Git will only knows about files that are in the directory that is.
So you have to physically bring
Yeah.
it in and then you add it to it.
Yes. So what you're adding there is you're adding it to the staging area. This is a bit weird because I'm adding the file for the first time. So add is a bit ambiguous. What you're adding is not actually files, it's changes. So what we're adding here is we're sort of adding, like, Git sees a new line, a new line, a new line, a new line, like all the lines appearing effectively. You could imagine it like that. If we make a change to this file later on, we could add the change to the file. We're not adding a new file, we're just adding the changes. That's what's happening.
So you're asking Git to rescan a file looking for changes?
Yeah. Yeah.
So does it do that now? Or no?
So it has done it. So I said add this, and it's gone, oh, so first off it goes, hold on, I don't know about a file called intro to Git. Oh, look, there is one here. I shall add it. I shall start monitoring this file from now on. And then it adds whatever was in there to begin with, because it's never seen the file before. So if I did, no, I won't. I'll show that later. But all we've done is added it to like this staging area. It hasn't actually, there's no commits. We haven't done anything yet. We've just told Git, okay, we want to do our first commit. And this is what we want to commit. Because you might have multiple changes in multiple files that you want to bundle together into a commit. I'll tell you what commits are later. So command number 3 would be a git commit. So let's git commit. I'm not used to writing it in longhand like this because I've set up loads of shortcuts. Git commit. So now it's going to open an editor so I can start writing some text for my commit. Add presentation notes. There we go. So you can have commits that are much longer than this. This is just like 3 words in a summary. Commits tend to have a summary, a blank line, and then as much description as you like. And there's a couple of conventions that you usually follow in commits and things that make a good commit message, but I'll cover those later. But this will do for now. Very simple commit. Explains what's happened. I've added the notes to the repo. And Git's telling me, okay, cool, I've recorded that you changed one file. There was 172 insertions. Those are the lines that were added. Now if I do git status, just to show you what's different, it says that we're on the branch master, and all of this stuff that it previously said, like changes to be committed and all that, none of that anymore because they've been committed. And if we wanted to then, for my, where were we? Step number 4, if I wanted to push this code somewhere else, because I didn't have to, I could just carry on working, and there's lots of people when they're developing code, they'll just be developing locally on their machine. They don't push it to anywhere, don't push it to GitHub, they don't need to. They're just using it on their machine to track their changes. But if I wanted to push it to somewhere else, I guess I could make a new repository on GitHub. So why not? Let's do that. Let's create a new repository on GitHub. Zarino, intro to Git. Let's make it public and create a repository. Cool. So now I can do what we had here. So git remote add. GitHub even gives me that command, so I don't have to type it all out myself. So let's do that. Cool. By convention, what we're doing here is we're giving this remote thing, this place we're going to push code to, we're giving it a name. By convention, you tend to call the first one origin, or you do on GitHub anyway, and then you're telling it how to get there. I've had to do some setting up to be able to push to GitHub. You need SSH keys and stuff like that, but GitHub guides you through that whole process when you sign up. And the final step would be to push it. So again, GitHub gives me that command, what I could run. It's very explicit here as to literally what I'm pushing. I don't actually need all of that, but all it's telling it to do is to push to that place that I just created called origin, and it's telling it which branch to push, which I'll cover later. There we go. Chug, chug, chug. Brilliant. It's pushed it, and now if I reload this page, there we go. Code is there. So there's a file called intro to Git, and that's the file that I just added. And there's one commit, which is the thing I just added. There's the description I typed in, and there's the change. So you can see there's, what did I say, 172? 172 lines that were added to that file. That's what's happened. So those are the 5 steps to creating a Git repo. So you could all leave now, and you would know how to start a new Git repo. So explaining what we just did. Right, files are tracked or untracked. So we had that thing where it told us about untracked files. That's where it doesn't know about that file. So now if I created a file like foobar. Okay. So if I open this in a file browser, there we go. We've got 2 files here, the intro to Git that we just were editing, and we've got like another file, an empty file. If we do git status, so Git knows about the file that we added. It doesn't know anything about this new untracked file. There's loads of different ways you could run git status, and one which I can tell people about later after the talk if you want. There's like a short way of, there's various flags that you could add to all these commands basically to modify how they look and the output it gives you. And lots of people sort of try and shorten the output to make it a bit clearer. So I tend to run it like this, and I see like question marks, which means Git doesn't know anything about that file. There you go. So that's an untracked file, and if I wanted to add it, then I would tell Git about it by saying git add for the first time, and it would start tracking that file from then on. We've been running git status all the way through this, so I don't need to explain that. And this idea of like changes, so I don't know, you might, for instance, if I were to, let's edit this file. So if I were to, I don't know, get rid of that whole section, and if I were to add some text here, say, now if I do git status on that file, it's telling us that there's this file that it's ignoring that we talked about earlier, that foobar file that I created. It's fine, it'll ignore it, you can leave it there, it's not a problem. It's telling us also that there are changes to this file, intro to Git, which I just made, that are not staged for commit. So there's this idea in Git of staging stuff, which is kind of unique to Git. There are other version control systems that don't have this concept of staging, where you, whenever you're like checking in your changes, it's literally taking the state of the files on disk at any given time and checking all of those in. Whereas that can be nice and simple for beginners, but it's more flexible if you can just commit like individual bits. So let's say in this, I might want to see what's changed. So I've run like git diff to see what's changed. And okay, so I've deleted this section and I edited that. So I've changed that line to that. Does that make sense to people? So it's like showing 2 different, the actual changes there. Okay. And it's even like chunked it up. So there's like a chunk here, and it shows us, poor Git, all it's got to go with, like at the command line, is like weird characters and like @ symbols and hashes and all sorts. So it tries to do its best. So it's showing us here that we're inside this file, intro to Git, and these are the lines that changed. So those are line numbers. And so line numbers down here too, showing us that there's like a second section of that file that changed. So there's obviously like lots of content in the file that it's just snipping out, because we don't need to see all of that, because that hasn't changed. So I could, if I wanted to, where were we? So I could add just the whole file like I did before, or I can add just like chunks of the file. Usually what you'll do when you're using Git professionally and a lot is you would be just adding like bits of files at a time rather than the whole file in one go often. So in this case, I might, for instance, want to make 2 commits out of this. So I might go like, I want to separately record the fact that I deleted that first section, and I would separately record the fact that I like modified a later section as well, added something about commits. So I could do like git add -p to add individually patches. That's what P stands for. So yes, I will stage that. No, I will not commit that bit yet. And now it tells me, in fact, I should run the proper command for you. There you go. So it's showing that there are some changes that are going to be committed, and there are some changes that are not going to be committed. And
Is it like a two-stage thing? First add and then commit?
yes. So you stage stuff first to like a staging area where you're like collecting everything together that you want to be part of this commit.
So everything that is in the staging area
Will be committed.
One
Yeah.
commit.
Yes. Yeah, that's
Could
the
you
idea.
still run this again and add the other things?
I could, yeah. So I could add a commit here. So like git, I'm going to do a shortcut here because I can't be bothered typing. Remove opening section. And now, oh no, I just committed both because I said AM. Shit. Git. Don't look behind the curtain. It's fine. Okay, we're back to where we were. Git add -p. Those are a load of shortcuts that you just saw. You can safely ignore those. I'll explain those to you later if you want after the talk. So yes, we wanted to add that. No, we didn't want to add that. Okay, now we're back to where we were, and I could do the thing I did earlier, but without the AM. Naughty. And so now all it's showing is that one change, and if we do the git diff again, we see that there's only one thing that's changed, and it's that second bit that we haven't committed yet. So we could add that too. We could get some more awesomeness. Oh no, we didn't add it. Yes. Now we can do it. Cool. The one thing you can do as well that might come in handy is that you can amend the previous commit. So if I thought that, like that, if I do git log, which I'll cover in a second, that shows me all of my commits so far today. We've added the notes to begin with, and then we did our first commit of removing that opening section, and then we added more awesomeness. If I wanted to change that, like I'd made a spelling mistake in that commit message or whatever, we could do git commit -- amend, and that will let me edit the text of that. More exclamation marks. Save it. And now git log will show me the updated version of that commit.
Does that only amend the name of the commit, not the contents of the
Anything. If I'd have added more, I could have added more code to the staging area and then done git commit amend, and it would have added it to the commit.
The same commit?
So yeah, so you could use it for either. Often you'll use that just because, like, oh, I forgot to add a file. I've missed a file out that needed to be added, or you made a typo in your commit message. That's what it tends to be, and that only does the most recent commit. It's just like a convenience thing. But
so you can only amend the most recent commit?
with that command, yeah. There's lots of ways that you can rewrite history, and I'll cover those in a sec.
Right, so the patching, can you explain chunks a bit? And is it literally line by line? So what defines a chunk and...
Yeah. I don't actually know what Git uses to decide what a chunk is or not. It usually gets it right. It bases it on the amount of space that's between lines that have changed.
So if there were a bunch of changes, what you end up with, sometimes it's wrong when it's like,
Yeah.
oh, I don't actually want to commit all of that. I want
Yes.
to commit a smaller chunk of that. And you
Yes,
can't
you
actually
can. So if I look back in my history, is it? Yeah, here you go. So this was back when I was adding those chunks. It's asking me, do you want to stage this chunk? And then it's got a bunch of characters after that. And those are all the commands I could have typed. So I typed yes. Why? Because I wanted to add that whole chunk. But you could have typed slash, I think. Or is it S? Why doesn't it say S? To be able to split the chunk. Or E, to be able to literally manually edit which lines by like adding minuses and pluses between the lines. You usually don't have to do that, but sometimes you do. It's points like that where like the visual Git clients are actually a bit better at this than editing it by text.
go and
Yeah.
talk about
Yeah.
later, just
Yeah.
to shut up. In practical terms, I mean, I get this bit, you go on GitHub, somebody says, oh, I discovered something wrong with this line, or other few bits, bug fixing.
Yeah.
I can get my head around that, but in practical terms, if you're starting fresh in the whole project, and like typing lots and lots of code, how do people normally do? I mean, do you sort of like sit there committing every 5 lines that you do, or do you sit there writing the whole day's worth of stuff and you commit a bunch of massive stuff? So as opposed to bug fixing, when you're really building, how does that normally work? But if you are going to talk about it later, then you can.
I was going to mention it, but I can mention it now. It's totally up to you what you want to do. I would recommend that you commit regularly as you're going. Like once you've made some like atomic change that makes sense on its own, commit that. Oh yeah, maybe you've added a function, defined the new function, and you've called it somewhere, and like that thing works, then commit it. Or sometimes you might not even have like created a thing that actually works yet. You're just part way through, and the doorbell's rang, and you need to go and answer the doorbell. You might just make a temporary commit of like work in progress, and come back later.
Well? So if you commit work in progress stuff, can you get rid of it later?
Yeah. So you can rewrite history totally.
Brilliant.
Anything you do in Git, you can undo, and all of that is, you can modify stuff like that. So yeah, we tend to do that sort of stuff at my society all the time, where we'll commit like a work in progress commit, because maybe it's got to the end of the day, you haven't finished making this thing that you were working on, but you want to commit it because you might get run over like that evening, and somebody else needs to carry on with the code you were writing, so you should really commit it. Or who knows what could happen, like your computer just doesn't start up the next day. Like you should really push all your work at the end of the day so that other people can work on it, or you should at least commit what you're working on. So yeah, generally though it would be like, this is a finished thing here, this little chunk of work. This makes sense on its own, like maybe it's doing a particular thing, or maybe it was a particular like feature that you've added or something that's fairly small. Like you can always do lots of small commits and then combine them later on, which is called squashing. And I'll talk about that in a little bit later, but that's what we tend to do. At my society, the way we tend to do it is we'd have lots of small commits that are all, maybe each one like ties up with a user story or some feature in a card somewhere, or some part of like a multi-step process or something. And then so we'd have like lots of these commits. All of those small little individual commits are really easy to go and review, because they're only changing one small thing at a time. So a reviewer can go through it and breeze through, oh yeah, I see he's added that to do that, brilliant, that one's sorted. He's done that to do that, and the test still passed, that's great. And he'll like go through them all really quickly. And then, once we're happy with that, we could just like combine them all into one commit if we think there's no real value to like, because lots of our products, our software gets reused by other people, and so we don't want to like force them to wade through hundreds of commits. It might be that actually, you know, like add header, add footer, change homepage title, like all of that stuff.
Yeah,
We could just combine those into one commit.
Maybe reviewing them later and stuff. If
Yeah.
you have hundreds and hundreds, it kind of goes the other way.
Yeah.
It becomes
Yeah.
messy.
It's often useful to have them as separate commits when you're first suggesting that as a bunch of changes, or when it's like you're submitting that pull request for the person who's reviewing the additions. But later on, it's not that useful potentially to people looking at history, because they've got to wade through all those commits. So you might make a decision there to combine all those commits. Once it's been approved by whoever's like owns the repository, like that looks great, let's merge this in. They might combine those all into one commit.
After it's been combined, then
Yeah.
Git forgets that each one's
Yes.
separate and it's all just one.
Yeah, you've rewritten history. Git knows nothing about that history that's been lost, sort of.
Can you get it back if you need to?
I thought it was.
You can get it back. It depends, yeah. It depends. There's loads of different permutations as to how that could have been done. That would mean there are various ways you could get it back. But canonically, you have rewritten the history, it has changed, so it's harder to get back to that previous state.
Yeah.
But it is still possible, sort of. Okay, so where were we? So all this time we've been doing, like, this was an example of git log, so showing those commits. And I've used the word commit a lot, and I don't know whether it kind of makes sense to people, but a commit is like checking something in. So it's like we've been talking about commits as like this sort of thing that you do, and Git is all about these commits, and they're like a change or a chunk of changes that make sense on their own, that can be described. A commit has an author, which is usually an author's name and their email address. It also has a committer, and those two people can sometimes be different. So you might have changes that have been authored by like a third party, somebody who's contributing to an open source piece of software. And then you'd have a committer, who would be the person who like looks after that piece of software and accepts the change in and commits it in under their name. People use authors and committers slightly differently. Sometimes, like, if you've come across the concept of pair programming, which is where you'd have like two people working on code at the same time, you might have like the driver be the person who's the author and the navigator be the committer. Some people do it like that, just so that both people get like attribution. And you also have like the date, and you have loads of these things, which are hashes. So that is, I don't want to get into describing how a hash works, because even I don't really understand how this works. But basically, this is like an identifier. It is almost guaranteed to be unique across all commits in that repo. It basically is. And it's based on literally all of the characters that are in all of the files in that repo at that particular point, sort of. So if you changed a file, if you committed something and then you did our little trick that we did earlier of git commit amend, and you like changed the character in the file and recommitted, it would be a totally different ID because the hash is based on what's in that commit. And you use it all the time to refer to individual commits. So you might, when you're merging in commits, or later on I'll mention like cherry picking commits out of different branches and doing all sorts of crazy stuff. All the time you're using these IDs because that refers to that commit. That's like the name of that commit, effectively. That's how you refer to it. And then you've got a description for commits. So the example I showed earlier of like the fix my street on GitHub. In fact, there's a pull request. Let's see whether there's a cool pull request going on. So, I don't know, here's a pull request from today showing a bunch of commits. So these commit messages, here's an example of a commit message that's a lot longer, which is great. So it's got a description and also a bunch of text about it. So that's, whether you're looking at the commit in GitHub or on the command line, like everything's the same. It's still got a commit hash, an ID, so you can mention it, who committed it, things like that. Right. God. Showing what's changed. So I talked about git log. You can pass all sorts of modifiers to all these commands that I'm talking about. There's almost fractal complexity to the git command because it's used by geeks, so it just gets more and more complex. But things like being able to show, I don't know, like git log -n2 will only show me the last 2 commits. Git log --patch will include a bit like where we added the chunks with git add -p. Remember that? We could show the chunks that were committed with git log -p. So that's showing me, here we go. So I ran git log. Here's the message I wrote, more awesomeness. That's my commit. And then it shows me like what the commit was. And then here's the next commit. This one was remove opening section. And there was the code that changed. Sorry. There you go. So there's all sorts of stuff you could do. People often have, you'll find lots of programmers define their own shortcut because we're all very picky about this. And I hate how after you're looking at lots of commits, you start getting really annoyed at how verbose all of this stuff is and how it fills your whole screen with output. So lots of people end up defining shortcuts like most developers will have their own favorite version of GitLog that they'll often call GitLG. And you can customize that. I think I had, there you go. So my version of GitLG is all of that. Obviously, I would not want to type that every time I want to see what has happened. But it can be useful for, like if I head back to fix my street, seeing as I seem to be using that as an example. Here's an example of a proper code base. So it's useful to be able to see 50 commits on my screen at once and to see lots more information about them all on one line. And you can do things like here, it's kind of a little bit trickier to tell, but here it's showing the sort of the commit graph, the trees. So those are commits that have happened in different branches. And I'll get to that. I'll get to that in a sec. So there we go. Branches. There we go. I was literally getting to branches. So one of the things I think I mentioned about commits, they've got hashes. They've also got parents. So each commit knows what its previous commit was, and commits build on each other over time. You can think of it like a family tree. So whether you've seen like grandparent, great-grandparent, whatever, and you see those ancestors going back, Git commits are sort of the same. So you can follow the tree of like where this commit went to and came from that, changed before that, changed before that. And that like lineage, that ancestry of a particular commit, often you'll have like a point at which that ancestry will fork off, and that's like a branch. That's called a branch. So the way this ends up getting used a lot is when you've got, like, Git was designed for the people working on the Linux kernel. To be able to work on this, you've got hundreds, thousands of developers all working across the world, all potentially working on, like, literally changing the same line in the same file sometimes, or that they'll be working on all these different things, and the idea was that they wanted to be able to work on them independently. And one way of doing that is through branches, so that you could start work, you create your own little branch, and it's like your own little sandbox to be working in. That means that it's safe from other people, and it doesn't have to worry about merging back in or even think about other people's work until the point that you want to merge back in, if that makes sense. Does that make sense? Sort of. Cool. So there are loads of conventions, again, about, just like there are conventions about how to write a good commit message or how much to commit at different points. There are loads of conventions about branches and how to use them, like feature branches and there's like something of like no pull switchyard or something. I don't know, there's like all this stuff. But basically, we tend to use them at My Society as like a feature branch idea. So when you begin work on a new ticket, you make a new branch. You branch off master or develop or whatever the main branch is. That's like the truth. This is the core, and then you branch off it and you start doing your work, adding commits, and then you do your pull request back in, and then your branch gets sucked back into master.
When you do a pull request, I'm assuming your code backs into the point where you started.
It can do. Yes. This, if I skip some stuff, because I know we're getting on a bit. There's an example there. When I commit, this is all now on GitHub, so you can read all these notes that I'm skipping. Oh, that's my excuse. So one of my questions was like, what happens if this core line, this master, has changed since you took the branch, and then you're merging back in? Often, when you do git merge, to merge the branch in, if you haven't edited the same files, if the files haven't changed between the two, then usually Git will know how to merge that back in. Even though changes have happened, it will go, oh, well, changes happen to these files over here, but that doesn't matter because this branch that's being merged in has only changed these files. That's fine. I'll just combine those, and it knows how to do that automatically. If the same files have changed, sometimes the same files have changed, but it's really obvious to Git that those changes don't conflict, and it might actually manage it itself. Sometimes, oftentimes, it won't. And so it will ask you to be able, it's like, okay, so what do you want to do here? You need to tell me as a human, because certain lines could change. It's not a genius, like it's just a program. It just knows that lines changed in a file. It doesn't know the meaning of those lines. It doesn't know that def blah colon means that you're defining a function. So it doesn't know if that line has been added or moved, appears to have moved in a file. Like, what does that mean? So it relies on a human to tell it. And so it will tell you that you need to resolve that commit, resolve that merge conflict is what it's called. Yes?
It can't cope with a spreadsheet then, like that.
It could do if the spreadsheet was a CSV. If it's like a text file, the spreadsheet, yes. If it's something like an Excel file, it sort of can't. Technically, I guess under the hood these days, an Excel file is an XML thing. It's like a zip file with XML files inside it. Git doesn't know anything about that. So yeah, if like we come across this all the time developing websites have images on them these days. And so like if you change a couple of pixels in the image, Git just goes, the file has changed, the whole file has changed. This looks like a different file to me. It would be the same with a spreadsheet, say. If you changed a couple of cells in a spreadsheet, saved that Excel file, Git would just go, this file, it calls it a blob, this file has changed, like, what do you want to do? It wouldn't be able to merge the file.
So Git deals mainly with text files.
Yes.
You can store the.
But you can, yeah.
Oh,
Yeah.
okay.
So you can store blob files, yeah.
Lying around and stuff, and you still have them in the same.
Yeah,
file.
yeah.
It just obviously can't deal with changes.
But exactly. There are, I think you can get extensions that allow you to do that. Extensions to Git itself so that it can handle special kinds of blob files and it can do stuff like merging them in, but most of the time you wouldn't do that. Because once you get to that point, you really should be using some sort of database to store your data in rather than spreadsheet files and things like that. So where was I? So yeah, the question that Jackie asked earlier, which was this when I'm merging in, things have changed, and you end up with this like merge commit, and when people come back and are looking at this, they see all these like this like Christmas tree effect of like all these branches that have been merged, and it can look a bit of a mess. And so some organizations or some whatever people looking after repos will be like, we'd actually prefer you to do rebasing instead rather than merging. And I don't want to get too deep into this because it's quite advanced, but basically rebasing is, you know, I talked about that like family tree of those commits. So each commit has a parent, parent. Rebasing is like saying, okay, you, imagine your parent was this instead. It's like transplanting that whole ancestry line onto a completely different family, or like changing who that grandparent was. I mean, the analogy starts breaking down because we can't physically change the DNA of people, but that's what rebasing is doing. It's changing that history. And because, remember I mentioned like all these commits are all based on these hashes. So like this short hash here, if I do the git log properly, then it's a nice long. Those hashes are based on literally what's in that commit. So if you change anything about that commit to Git, it's a completely different commit. It's a completely different hash. So if you edit that history, it's sort of like creating a whole new alternate reality for that family in that family tree, which can be really useful. So when you're merging back in, we can sort of pretend that this branch I took, rather than me starting that branch a week ago, 100 commits ago, I'll just pretend that I like took that branch like literally right now, and then I did all these commits, and then I committed them back in right now. And then you wouldn't end up with those merge commits, if that makes sense. That's an alternative to merging in.
So is it the equivalent of really kind of detaching your branch and attaching it higher up the tree?
Yeah, exactly that. So all of those commits that have happened since in master would appear in your branch again. And that means that when you merge them back in, Git's like, hey, super, okie doke. It just merges it back in because there's no conflict anymore because all those commits are in your branch. So that can be really powerful for when you want to be able to like make a really simple history that's really easy to follow. Or it can be that you want to do what I mentioned earlier, which is like combining lots of commits into one. That's rebasing too, because basically you're rewriting history. That's what a rebase is. So it's, with great power comes great responsibility. So like you're modifying the history, which means that once you've pushed that back to GitHub, other people who've cloned your repo, next time they pull, like they'll go, whoa, Git will complain at them and say like, there are conflicts here, like you need to do stuff, and they'll be like, what on earth happened here? So if they're good at Git, they'll be able to work out what happened. But generally you want to try and, if you're going to rebase stuff, you should really only do it on like that example I gave of like, you've made your own branch, it's your private sandbox, you can rebase that to your heart's content because you know that you're the only person working on that. But once you generally don't want to be rebasing other people's work because that could confuse matters. They could pull it and they'll be like, whoa, what happened to all my commits? Like things have changed. And they can get back to that and they can pull the changes and whatever, but it's sort of rude to do that.
So is rebasing then kind of like saying to the merge conflicts, screw the merge conflicts, I'm just going to force overwrite the files?
Yeah, it's in a way, yeah. Because you're manually including those changes, it might mean that the merge conflicts sort of come out in the wash because it's more obvious now what's changed.
Would it be exactly the same as cloning the repository again into a different directory above as well, and then just copying your changes literally over the files? Is it kind of the same thing, or is it not like that? What is the additional power that you get other than just overwriting the files?
Because we're talking about commits rather than files.
Right.
So you're literally taking the commits themselves, the changes, those chunks that we've added, those changes. That's what we're changing rather than the files necessarily, in a way. So yes, you could do it that way, like literally copying the files, like remaking those changes.
That's what I do when I'm just
Yeah.
I haven't done any rebasing.
Yeah, you could do that, but rebasing is just, I guess, a cleaner way of doing it and easier. And it changes all those commit hashes. That's the dangerous side. Like you've changed the identity of these commits, so that can make things complicated later on. But it's not all bad. I've got some notes here about like if at any point during a commit you're feeling worried or it feels dangerous, like it's not a problem. You can abort any merge. You can abort any rebase. -- abort, like get back to a safe position, not a problem. And if you're doing this rewriting of history and you think, shit, I just got rid of like this commit, it's gone. What happened? Like you can almost always get it back. Git reflog like shows you all it's almost like the recycle bin in or the trash can on the Mac or recycle. I don't know. What does Linux have these days? Does it have recycle bins? Whatever, yeah. So those commits, it actually, because it knows you're only human and you make these mistakes, like those commits are actually almost always still hanging around a little bit. So you could go back and pull that commit back out if you really wanted to. I won't go into how you do that, but just know that it is there. And this is this idea, git rebase -i, standing for interactive. This is this idea of like being able to rebase a bunch of changes. So I'll show you an example of what that looks like. If I was in, in fact, I've got a bunch of commits here. So I've got 3 commits. If I did git rebase -i head 3, 2, yeah. We won't go into why that didn't work. So it's showing me what those commits were. So I've told it, I want to rebase the last 2 commits. I want to edit those last 2 commits. And it's letting me know what I could even do. So here's all the commands I could do. Oh my God. So I could like change the wording of a particular commit. So earlier you said, can you only edit the most recent commit? No, you could edit a previous one. So like if I wanted to edit not the most recent commit, but the one before it, I could type E there instead of pick, and then it'll let me edit that commit. Or I might want to combine those two commits, so I might squash it, so that commit gets squashed. I'm zooming over this at light speed, and if I'm in this and I don't want to apply that, I can just get rid of everything in there and save it, and it will go, okie doke, nothing to do, that's fine. It hasn't done anything, because I didn't tell it what I wanted to do. And everything's back to how it was a second ago. Git log.
So the interactive mode literally opens up
Yeah.
a bunch of commands where
Yeah.
you change things, and when you just save the file, it automatically executes all
Yes.
the commands?
Yes. So, and that in a complex rebase, that might be like, it will basically what it's doing is stepping through each commit and applying the change you've said. So it will like look at the two things and go, is there a merge conflict now? And if there is, it will stop and let you edit it. And if there isn't, it will just carry on to the next commit. And actually, as you do it, you like see it go through all the commits and goes da 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 da, da, and it says like done, great, and that's it rebased. If you're lucky. If you're unlucky, then you have to stop at each point and like edit stuff to fix conflicts or whatever. So that's pull requests and branches, and that's kind of the end of what I was going to talk about. I was ending with the great responsibility thing of like, if you are going to edit history, it can get a bit complex. I know lots of people, I've had people complain at me when I've introduced total newbies at Git. I've introduced them to rebasing in like the first half hour, and people have been like, you shouldn't tell them about that yet because they'll just ruin everything. And I'm like, no, you need to know about this because it's like the best thing about Git is that you can edit all of that history. It's a responsibility though, because other people might be relying on that history. So we do it at my society. We're a small team. We can just announce on Slack, hey, I'm just going to rebase this branch. Is everyone okay with that? And they go, yeah. Or you might, for instance, know that, well, I've not really worked on this branch for a long time, so I'll come along, start working on the branch, like git reset to, or whatever, reset, blah, 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 blah. Reset to like the most recent version of it, because my local copy is probably out of date. It's probably being rebased in the meantime. I don't want to go through like accepting those changes bit by bit. I'll just reset to what it looks like right now. You can do that when you're a small team. When you're a huge, if you're like submitting a pull request to like Node.js or something, then you probably wouldn't want to rewrite the history of that because they will not like that. And there's a couple of like interesting tidbits that might come in useful at various points. Like earlier on, I did like a git undo commit when I made a mistake, and I said, don't look behind the curtain. This is what that was actually running in the background. It was basically doing a rebase. It was undoing that previous commit. There's a cool thing that I literally only found out about today, is this instaweb command, which is so cute. If you look at this and you're like, I don't know what that means, it turns out you can run like git instaweb, and it literally opens like a web browser version of your code, and it shows you all the commits. And this is like running on my computer. I thought this is so awesome. And that's like kind of cool. So there's loads of, as I say, like all this complexity that is in there, things you can do. There's loads of ways of referring to things. So you'll note like here I've used, oops, I keep double clicking and it keeps jumping around. I used head, and I've used like head, caret, and I've used like dash. And there's all these ways of referring to previous commits and referring to previous branches, or this one, dash, is really cool. It's like the branch that you had checked out most recently, but not the current branch. So like you could check out somebody's branch, have a look at it, then go back to master, check out master, and then just merge in, oh, what was the name of their branch? Never mind, I can just type dash, and that refers to like the previous command. It's not very easy for beginners to remember this stuff, but it's handy when you're like years down the line and you're like just typing away like the cat in the GIF. Yeah.
Can you demonstrate the amending thing for adding new track files? Because usually what I do is I reset soft and then I undo that commit by doing that, but that's not
okay. Yeah, I would.
Like say I've forgotten to add a file or.
Yeah. What I would do is, let's say, I want to add a bit more awesomeness to my more awesomeness commit. So we changed this and we added the, where's our exclamation marks? I can't remember. Oh yeah, more awesome. So they're awesome and even really more awesome. Okay, so this commit, I really should combine this change that I just made. I should combine it into the previous commit that added the more awesome, let's say. So yeah, so I've got that more awesomeness commit that was already made.
So it's not pushed yet, but you want to add it before you push it?
Yeah, it's yeah, it might already have been pushed. In fact, if I do git push, yeah, can't type, git pew. So now that will be on GitHub, those 3 commits I made. So that was what my history looked like on GitHub 25 minutes ago. And now it's got all 3 commits. Okay, great, I've pushed that. Now, what's the state of my repo? Okay, there's a change to that intro to Git file. Okay, I wonder what that is. So I could find out with git diff. The diff was that I've added that last bit of text. Okay, cool. What I'd really like to do is add that to my previous commit, let's say. I could use git commit -- amend, sort of. What I'd really probably do is do git commit. In this case, I might do -a because I know that there's that's the only change that I've made in -a says commit every change that's happened here. In this case, the only change is 1 line. So in this case, rather than adding that file manually, I just type -a because it's quicker. Git commit -a rather than having to add the file. And I am fixing up the previous commit, so I might be fix up to say that it's, I'll explain why later, and the previous commit, which is head.
So you're fixing up the previous commit?
Yes.
And you can refer to the commit by its hash?
I could refer to it by its hash, so here, that hash, I could copy that, and I could paste it in there. Could
you edit long lost history as well?
Oh yeah, so I could fix up that commit, even though it was literally the first commit in the repo. I could fix up that commit, and then it would change the hashes of all the descendants as well,
right?
Because the history has changed. But yeah, in this case, I only wanted to edit the most recent command, so I think I can do head. Yes.
Would actually going back and using fix up on a a really long commit be the worst thing you could possibly do in a repo?
Yes. It would be not very nice to do that if people weren't expecting it. But there might be cases where you might want to do that. There might be some idiot when they first created this repository committed the password to something, and we need to expunge that from the history of the entire repository. I have had to do that before, and you can do that. The danger is oops, you pushed it to GitHub in a public repo that's already been indexed by Google. Tough. Trying to change that password or change that API key. But there are cases where you might just be able to rewrite the entire history of the repo like that to get rid of a particular file or something.
But even though the further commits, the more recent commits, don't use or reference the other commits in any way, or the other files that were in that commit, it still changes all the subsequent hashes. Yeah,
it will still change, because I think part of, I'm sure Git experts will be screaming this when they're watching this on YouTube in the future, but I think the git commit hash, it hashes both the change and the parent's commit hash, because this is all getting into almost blockchain sort of levels of complexity, but basically, yes, if the parent has changed at all, then the current commit will change too, which means that just cascades all the way down. It's like a domino effect. So if you've changed something really far back in history, all the changes after that will change
even if
too.
The files aren't really
even if nothing has changed about that commit, all that's changed is its parent. And the only reason that its parent has changed is because its parent changed. And the only reason its parent has changed is because
some miracle tree thing.
So anyway, sorry. Where we were was I was demonstrating this fix-up. So now if I do git I'll do my shortcut of git lug because I can't be bothered with all that text. We've got this new commit here. So like if we compare it with how this all looked on GitHub, we've got this commit here. I don't know whether that's quite small text, isn't it? But that most recent commit was 3A4C283. So that's that one there. 3A4C28 whatever. And now we've got a new commit. And the name for this commit starts with the word fixup. And it's like being sort of specially marked as like, this is a fixup commit. So that if I did git rebase -i, let's say I wanted to do it the most recent 3 commits, let's say.
-i identifier?
-i is interactive mode. I could have typed -- interactive, but that's like 12 characters, and I don't want to do that. So here, it's showing us, okay, well, what do you want to do? Remember, we've seen this screen before where you can edit stuff. And it's already, because I used this fix-up thing, it's already gone, aha, so you really didn't want to keep this commit around. What you wanted to do is squash it into the previous commit. And so it's done that. If I'd have like fixed up a commit way further back in history, it would automatically like take that line and put it up further up in the history for me. So I go, yeah, that's great, save, close that, and it does all that, it rebases it, and now my git lug looks like that. So that's my entire history. It's taken those 2 commits, that A72 whatever, and 3A4, and it's combined them into one new commit, B92 whatever. But you'll notice the parents haven't been changed at all. So the parents, 96, that's the grandparent, 96F, blah, and D12, blah, they're the same in the new alternate reality, like new universe now. We've rebased stuff, but those 2 grandparents are the same because we didn't change that far back in history. We only combined those 2, like the child and the whatever, the next the next child. There's no word in English for future child. So then if we tried to push that, Git's going to complain because it's going, well, hold on a second. You wanted to push some commits, but GitHub is telling me, this is my computer saying, GitHub's telling me that it doesn't recognize like the thing at the tip of the branch, like what has happened here. And it's because as far as GitHub's concerned, the most recent commit is 3A4C blah, and yet my Mac is pushing this whole history, and there is no 3A4C anymore. And it's going, well, what on earth is that? Is that a new commit that somebody's added to the history in GitHub that my Mac doesn't know about? Because as I said, like you've changed history, that, as far as Git's concerned, that doesn't exist anymore. So it doesn't know whether that's a new commit that someone's committed that you really want to keep, and maybe you should pull that into your local history, or maybe it's something, as I did, that I've combined some commits and I want to get rid of it.
Say you have done that in your local history and you want your own source to follow,
Yeah.
How do you only track that specific commit? How do you get rid of it and say, oh, I don't actually want to submit that, I want to keep that for myself? Is that a git stash or something? Because I don't really know how to use stash.
Yeah, sort of. If you temporarily wanted to do that, you would... Yes, you could stash changes. You stash changes rather than commits. So that's like temporarily, if you wanted to... it's almost like when you've got like a messy desk and you've got loads of things on the go and you're just like, I just want to focus on one thing at a time. I'm going to stash this, this, and this, and you just put it to one side.
You stash the staged commits?
You stash like changes to lines, almost. It's like, but that's really only a temporary thing, and you'd want to unstash relatively soon. It would be crazy to like, let's say you'd copied someone's code, and you'd like made some changes to their code to work in your particular situation, and you were like, that's really useful to you. You would really want to commit that rather than just keeping it hanging around in stash, because it's not being committed anywhere. It's a bit more likely that it could get lost. So what you'd probably do is create your own branch, add your commit your change, like the tip of your branch, and then every now and then you would like rebase your branch onto the latest version of master. So you're basically sucking in the changes that have happened upstream.
Yeah. A lot of this I just end up copying it to a directory above and just not actually using the git commands at all, which is what a habit
Yeah. Now you know you don't need to do that. Yeah. In this case, like, I actually made that change. I added some more awesomeness, even more awesomeness, to that line. And I'm perfectly happy that these 3 commits that I'm pushing, like, I want that to be the actual record, like that. I'm happy with that. And I know that I'm the only person who's using this Git repo on GitHub. Like, it's perfectly fine for me to push and change that history. So I could force the push, which it tells me about somewhere. Oh, in fact, it doesn't. But you could git push -- force, and it will force that push, and it will lose the commit on GitHub.
What if 100 pushes have been submitted in this meantime, and you just force pushed?
Yeah, that's why you shouldn't.
Actually overwrite that?
Yes,
yeah.
That's why you shouldn't do it.
Remember
when I told you not to do it? Yeah. That's why you shouldn't do it. But because I know I'm the only person editing that repo, and because I know, like, in reality, you would be pushing to a branch that you work on and nobody else works on, so it's safe to do that.
Would it be also safe to pull really quickly before you did
this?
And then?
Yeah, you could do. Yeah.
Briefly, more in terms of terminology than the details.
Yeah.
So you have the repo on GitHub.
Yeah.
You are a contributor.
Yeah.
So you have kind of direct access to it, and you
Yeah.
can push stuff
Yeah.
willy-nilly. A pull request is a suggestion by somebody else who doesn't have access directly.
Or, well, I mean, like here on, have I still got? Yeah. Here's the example on Fix My Street. So we've got here Matthew has started this pull request, and he is asking for approval from Struan to review that. We've both of them are developers at My Society. Like, we've got push access to the repo.
When will you not push but do pull request when you don't have the authority, or?
In this case, we do it just because part of the way we develop at My Society is that all code that gets added is reviewed by somebody. So in the olden days, before GitHub, you would take your change, you would like do I don't actually know, there's like commands that you just don't use anymore. I guess Linus Torvalds probably uses them, but nobody else does. And you'd effectively be doing something like git log -- patch, but there'll be much better ways of doing this. And you'd be like taking that output and you would copy it and paste it into an email and send it to somebody and say, can you review this change? And they would copy the thing and paste it in. Like, that's a literal patch. And GitHub's got all this stuff inside of it that it understands this output and is able to work on that. You don't do that anymore. Instead, you do pull requests.
I've just sent you a pull request, by the way.
Before tonight, you were just doing pushes. I take it that you'd use different commands if you wanted to send your commit as a pull request.
Yeah, so you can't do that direct. A pull request is like a GitHub thing. It's not a Git thing.
Oh, I see.
So issues, pull requests, forks, they're all GitHub things, not Git things. So you can't make a pull request from Git.
Okay.
There are command line clients for GitHub, like Hub, which lets you create a pull request from the command line. But a pull request is a GitHub thing. It's not a Git thing, so you can't create it from the command line. You could obviously, it works off branches, and a branch is a Git thing. So you would push your changes to a branch, and then you go into GitHub and make a pull request out of that branch.
So is that how normally people work? They will do a branch of somebody else's repository, do some work, and from there...
Yeah, they would do a fork. So what Matthew's just done, which is great, is an example of him forking my repository. So he came along on GitHub, saw my repo, and he clicked the button up here called fork. And I can tell he's done that because there's a number 1 next to my repository saying that he forked it. So let's go visit his fork. So here's his fork of my repository. It's his copy. What it does is show that it's got a bunch of commits in it. As it happens, his fork only includes, on the master branch, everything that's in my master. He's added a new branch called patch 1. I don't know whether he made that manually or whether GitHub made it for him.
It made it for me.
Yeah. And he's added a commit that updates something. He's added a not awesome heading. And then he's pressed the button in GitHub that lets him create a pull request automatically out of that branch that he's created. Is there a way to get there from here?
You are now in Matthew's.
We're in Matthew's fork of my repository on GitHub.
When it says master, does it mean that it's his master or your master?
That's his master.
Okay, so everybody has a master.
Everybody has a master branch. If the original repository, he could delete his copy of the master branch in his repository if he wanted to.
And doesn't that delete everything?
No, just deletes that branch. All the commits are still there if they're still referenced by any other bit of the family tree.
This is why blobs don't work, because nothing's ever truly gone, is it? The history's all still there, so that's why blobs don't work. Because it's all cumulative. There's no way to actually get rid of the commits, is there?
There probably is a way to get rid of the commits.
Yeah.
But yeah, in a way, like as I was saying before, like Git stores all of this stuff, and like all those commits are still there, even if like there was all these master branch and you deleted the master branch. As long as there's still another branch that included all those commits, they still exist. You could recreate the master branch based on this commit. Branches are kind of like, there's things called tags as well in GitHub, and it's like just a name. A branch is just a name for that combination of commits, that branch of the family tree. That's all the branch is. It's just a name that's applied right at the end of it to say this is that branch. So you're not really deleting all the commits. When you delete a branch, you're just deleting that name. You're just removing the name. All the commits are still there, but they're just sort of hanging around.
Anything that's above the junction point?
Is there?
It doesn't actually delete everything.
No.
All the commits that are above the 14 point.
If you deleted the branch, you're just deleting like the shorthand, the name for that, the convenience name for all of those commits, that particular path through the ancestry of commits. That's what a branch is. It's a weird thing. There's probably better ways of explaining it that I don't know, but that's kind of the way I think of it, like a family tree, and it's just like the name for like this person with this father, with this father, with this father, with this father. Like that is the name of a branch. It's not the actual people. It's just the relationships and the history of that. So if you deleted the branch, you're just getting rid of the sort of the easy tag that's added to let you easily refer to that. Like the history of all those commits is still there. It's just that they're harder to reference because they haven't got a name anymore. Like that particular path through history hasn't got a name.
Can't quite figure out where to join it back into the
Yeah,
history.
but you could create a new branch. You could check out that point in history and like create a new branch from that. Now it's got a name again.
I'm a bit confused about checkout. Can we explain what checking out is?
So checking out, this is an annoying thing about Git. Checkout has different meanings in different places, which is really annoying. You can check out files and you can check out commits and you can check out branches. And I'm sure to the developers of Git this all made sense, and it was very sensible because there's like some mathematical purity to the idea, but it's kind of confusing. But when you're checking out, you're basically like updating the state of all the files on your disk, or at least all the tracked files, because remember that you can have files that are untracked that Git just ignores and just leaves. If they're on your disk, it doesn't care. But you're updating the state of all those based on like the thing that you're checking out. So I might, for instance, like this pull request that Matt's made, if I head back to my repo, because I can't find a way of getting to his pull request, if I go back and have a look at this pull request, what would probably happen, like in my day job at my society, rather than just looking at the pull request, like this pull request that Matthew and Struan have been working on and going, yeah, that looks good enough, yeah, I'll commit, I'll merge that. What we probably really do is check it out locally, check out the branch locally, run the tests locally maybe to check that they actually work, and then we'd merge it all locally rather than doing it through GitHub. So in this case, I'll do that with Matt's pull request. So he's submitted this pull request, and what it's done is like created a branch that I could check out. In fact, I probably won't do that because it's getting a bit late.
If you check out, does it do a full copy of the repo at that branch stage?
What it's doing is applying all of those commits that you're checking out in a way, I guess. But yeah, it's effectively creating like
to the repo on your computer?
yeah. It's not overwriting anything. It's not changing anything. You can always get back to what it was before. It's just like creating this alternate branch, effectively.
I'm guessing if you want to go back to work on what you are doing, you have to kind of switch out.
Yeah, you would check out the branch that you were in before. Anyway, you can also like check out past points in history. So you could, if like I'd changed lots of files, I can do like just git check out this directory at this point, and it basically undoes all the changes that haven't been committed, for instance.
Jumping to the registry at different
Exactly.
points.
Yes, exactly. I should have said that earlier. It's a way of jumping between points, and that might be points in the past, or it might be points on different branches, or it might be points like in a branch that someone else created. Yeah.
Do you have a quick command that shows you where you are? Like if you did a checkout, how do you know quickly?
Git status shows you, sort of, or...
I mean, how do you keep track of where you are if you've done several checkouts and moved around? How do you know where you are anymore?
So I would know here, for instance, that I'm on master by git status. So that's told me which branch I'm on or like what point we're at. And it would also show me whether there had been any changes. So I know sort of roughly where I am. I guess if you'd like checked out a particular commit, you weren't actually on like the tip of a particular branch. You were somewhere in history. If I go back, if I do GitLug again to, like, let's check out this point in the history. If I check that out, I'm now in what Git calls a detached head state. It's where you're not actually at the end of a particular, like those family trees. You're not at the like present day. You're somewhere in the history, and you're sort of detached from the real branch. So if I did git status now, it tells me I'm not on master anymore. I'm detached at this commit. So you can always tell where you are by running git status. Or I guess you could do like git log, like -n1 to show me only the most recent commit, and there I am. So even though there are more commits in this whole repository on various other branches, I'm not on that branch right now. The branch I'm on right now is like this sort of weird temporary branch that I've sort of temporarily created by checking out, by, as you said, like jumping to that point in the past. And that's created this sort of detached head, fake, temporary branch, and that's all that's in there, is like if I did git log, like there's only one commit as far as we're aware. And so you might get really confused and go, oh, I've lost all of my commits, what's happened? Like, but actually, git status shows you that you're in this weird detached head state. And if you checked out master again, then you're back on master. Git log shows you all the commits. Like, there you go.
The notion of head is kind of the tip in Git?
Yes.
The
Head is the thing,
latest.
the latest thing on the branch you're currently on. Yeah.
I was just going to say that I read on Twitter somewhere, so this is very good authority recently.
Probably
that-
better authority
that-
than me. Yeah.
That there's going to be something new in an upcoming update with Git, that checkout is there's going to be split up into some different commands.
Oh, that would be amazing.
So checkout doesn't always mean the 3 or 4 different things
Yeah.
it's always supposed to mean. Like, so if you just want to like destroy all your changes to a file, you don't have to check out the file
Yeah.
again. You can just say like git destroy whatever it's going to be.
Oh, that's a good idea.
So watch that space. I've been trying to find what it is. I can't find it. but I think that's going to change
Yeah.
at some point. So, or
I
not
mean-
change, but there'll be additional commands you can
Yeah.
use to do specific
Yeah.
things. That I think are supposed to make a bit more sense.
But yeah, probably make it a bit easier for newcomers to
Yeah.
work out what's happening, because it is often confusing, the fact that you can check out so many different things.
Yeah.
And you often end up having to do, in fact, did I have an example of this in my notes? I'm sure I had double dash somewhere. Yeah. So sometimes you end up having to do this, where you've got like 2 dashes. And that's a bit of a hack to tell Git, I'm talking about files now rather than other things, because you might have like a branch, and the name of the branch is like foobar, but you might also have a file on disk called foobar. So when you say git checkout foobar, Git's going to be like, do you mean the file or the branch name? What thing? What are you trying to check out? I guess you could even theoretically have, by some miracle, you could have like a file named after a commit hash, and you're like git checkout whatever, and it's like, well, is that a commit hash or a file? Like, it could get a bit confusing.
But that's just standard GNU root line stuff, isn't it?
Right, yes,
You put dash dash and it says stop treating
Yeah.
exceptions.
exactly.
If you're trying to remove a file called
Yeah.
dash F, you can
Yeah.
select that.
Yeah, exactly. So you end up having to do this sort of stuff just to be able to get around the fact of like telling it when you're talking about files and when you're talking about special things like branch names and stuff.
So can you check out a single file and then that won't change all the state of your repo, will only change that file?
Check out a single file.
Because you're talking about checking out a file.
Yeah,
And
So that-
checking
yeah,
out
that would be
the
like-
commit, so if you're going to commit, then obviously everything goes to the stage that
Yeah.
that commit was. But you're talking about checking out a file.
so like checking out a file would undo any uncommitted changes to that file, if that made sense. So let's say I edit that file. Let's say I just delete everything in that file. So the file now has no content. If I did git status, I can see that a bunch of changes have been made to that file because it's showing an N. If I did the proper status, then it's showing it's been modified. And if I git diff, it shows me what actually changed. Oh my God, somebody came along and deleted all this text in this file. So I could, as I say, git status shows that it's unstaged. It's not staged for commit yet. It hasn't been staged. I haven't run git add. Like, nothing has happened to that. I could do git check out that file, and everything will be back to normal.
So it brings it back
Ta-da!
from before the latest changes.
Yeah, it basically just blows away any changes that haven't been committed.
So I can see why you're saying that checkout means completely different things.
Yeah.
Because jumping between commits and what you just did is like totally
Yeah.
unrelated.
Under the hood, they're kind of the same. It's very weird. What's really happened is you're kind of checking out how that file looked at a particular point in the history, and I just haven't mentioned what point in the history it was, and Git assumes it was the most recent version of the history.
Yeah, but it gets a bit fuzzy because there was no commit, there was no actual data attached to that, so I know Git keeps track of that, but
Yeah.
also when I talk about changes, they would never really,
Yeah. So that's how you might, like, I sometimes do that, where you'll just check out, I made some changes, I did a little experiment in a file, it didn't work out, git checkout. What I tend to do is git co dot, because I've got a shortcut for checkout, which is co, because I don't want to type checkout all the time. All these changes are in your twiddle/.gitconfig. So there's a file there which I won't open because I think it's got my GitHub token in it, and I know this is being recorded. But you'll just have to imagine what's in that file, all the goodies that are in there. But you can put all sorts of shortcuts in there if you want for various different files. So I mentioned earlier that I have a shortcut of LivLUG, which is a short version of what's the history of a file, of a branch. But yeah, like gitster was an example of a short version of git status that I've set up and all sorts, and git co. And the git co dot, or git checkout dot, if you wanted to do the original version, that just dot refers to like as exactly like it normally would, and then it's like the current directory. So it's like just blow away any changes in the current directory like that haven't been committed yet. Current directory dot.
And haven't been committed, not staged.
That haven't been, I don't know. It's a good question. Let's find out. If I git start, okay, git add intro. I haven't committed those yet. They've been staged. Git co. Yeah, still there. So it's anything that hasn't been staged. Interesting. There you go. I've learned something new.
Do you know about submodules? And when do you want to like have a different repo for things?
Yeah. Submodules are just if you have a Git repo inside another Git repo. So let's say I GitHub Bootstrap. Let's add Bootstrap SAS or Bootstrap. There we go. Let's say for some reason I wanted to check out the entirety of Bootstrap into my repo. So maybe we actually do this at my society sometimes. We'll have like a common library of tools that lots of other sites need to use. And so we'll include those as a Git submodule. So we check it out. So like
but
here
most
we go.
importantly, like I'm just worried about like whatever change happens in that thing. You want it to be shared and you want it to be a submodule, but like you want it to be a specific version of that repo. And if it changes, well, they've just screwed up your code.
Yeah.
You know what I mean?
Yes and no. So this is just cloning all the history of Bootstrap. I probably should have picked a smaller repository. So if I ls now, we've now got, in fact, let's do that. So we've now got a directory there called Bootstrap, because I just cloned this Bootstrap repo into my repo. So we're in my repo and I've got a Git file, a .git file directory. If I have a look what's inside this Bootstrap directory that's just been created, that also has its own .git file. And if I do git status, Git by default doesn't track files until you tell it to track a file. So it just knows that, oh, look, a directory appeared and it's called Bootstrap. But if I add Bootstrap, the directory, now it knows that all these files appear to have been added, and it also knows that that's a submodule, I think. And if you changed it, what it's actually done is like checked out a particular commit of that submodule, so that even if the submodule changed, you'd still be running that old version of that commit until you updated. Yeah. Well, even in the repo, like the repo, it doesn't actually contain the. Oh no, that's actually added. That I guess you do git submodule add, and then it would know. Sorry, I've just shown you the wrong thing. But you would git submodule add that thing, and then it would basically just keep a reference to which point in the history of that submodule you've got checked out in your Git repo, and that way, when other people cloned your Git repo, for instance, they would clone out that submodule at that particular point in the history of that submodule.
So what happens now if you were to add this and push it? Does it add it as a submodule, or does it just add the files raw?
In this case, because I added the file, I checked out, I cloned the thing rather than adding it as a submodule. So here it would actually add it all.
I've done this and it complains about it and says it's going to add it as a submodule anyway.
Ah, interesting. I don't know. What would it do? Let's check out this, because I don't care about this anymore. So now all we've got is all of this stuff. What's happened here? Git. Yeah, it doesn't know that that's a submodule.
When you go and push it, I swear it complains.
If I git reset dash hard
It's just
origin
really
master.
completely.
So now we're back to how we were. ls minus la. There's still a bootstrap folder there, which shouldn't be there. Let's get rid of that foobar.txt too. Okay. So I think git submodule add that or something. I can't remember how you add a sub. How do you add a submodule?
You misspelled bootstrap.
I
You put bootstrap into.
No, that shouldn't
Is
matter.
that right?
I think it's before the URL. I think the URL comes before the name.
Maybe it just works it out. Yeah,
It does, yeah.
just works it out.
Oh, because you can't rename it because it needs to be the same as the.
Yeah, I don't know. I think you can define a custom name for it. So now, let's see what it looks like. Sorry, this is getting a bit intense for an introductory course. But here, now, because I actually properly added it as a submodule rather than just adding all the files from scratch, now it's created this git modules file.
Okay.
And if we open that git modules file, we'll see that it's listing, okay, this is the submodule, this is where it is, so that's like you could change the name of that directory, and this is the remote that it's based on, this is where it came from. So if I was to go into a Bootstrap directory, oh no, what did I just do? Nothing, good. I didn't want to do that. I wanted to cd into Bootstrap. So now we're inside this folder with loads of stuff in it. If I do git log inside here, I'm inside that repo. I'm not inside the upper repo anymore. Because the git index is here. There is a .git file here. If I ls-la, we'll see that there's a .git file there, or directory. If I do git log in here, there's all these commits that are like, these are the commits from Bootstrap on whatever branch it's currently on, which will be master by default. I could check out a different branch or some other point in the history. So let's say I wanted to roll back to a previous version or something of this submodule. I could git check out that past version. And if I go back into the parent repository, git status will show me that things have changed, I think. Modified, Bootstrap, new commits.
Oh, wow. So you can, as the maintainer, you can choose which version.
And I can choose which version of that submodule I want to use in my repo. So we do this, I've done this with Bootstrap, or with like the government digital service has really good like open source prototyping libraries and stuff and themes, like themes for websites. You can check them out, but I don't want the latest cutting edge version of master. I want like version 3 of Bootstrap. I don't want like the latest one they're working on. So you just check out branch v3 of Bootstrap, and then that's the one that you use in your repo.
And then if I clone your repo, it will clone.
It would clone, exactly. Yeah.
That's really good.
Yeah, it's super useful. Super useful way of doing that. So you could, if you wanted to, if you've got like lots of things that you are using in multiple products, then you could abstract them out into a single submodule that you then include into all of your repos if you wanted to.
So they do the version, you say you check out version 3, is that done in a branch that you say?
Yeah, there might be a branch or a tag. Branches and tags are basically the same thing that they will have named. So yeah, in your case, like patch 1 was the name of that branch that GitHub created. So you could like check out patch 1. I could clone your repository, your fork of my repo. I could clone it as a submodule into my own repo. That would work. I can't see why not. And then I could like check out your branch of, yeah, that would be weird, but you could do that. Yeah. Hey?
Some of us are beginners.
Yeah, sorry. Yeah, that's a bit crazy. Yeah. I can't see why that wouldn't work. Anyway, sorry, I'm losing my voice because I've been talking for ages, but hopefully.
I've noticed you start to put on the git command before every command that you want.
Yeah, because I've just been typing git so much, I'm like, git ls? No, there is no such thing as git ls. But yeah, if you need any help, and one of my colleagues at my society pointed out an example of a useful website if you're more of a visual learner. This was kind of cool in that it like explains this idea of branches by like getting you to type in commands. So I don't know whether you can see that particularly well, but if I zoom in a bit more, there you go. So like git commit, like it's showing you how the branches change and how you could check out other branches. So like there's an example of some branches, like I might git check out dev. Oh, it doesn't know my shortcuts, of course. Check out dev. So now we've like head has switched to dev and stuff like that. So there's a link there. That's under github.com/Zarino/intro to Git. For forevermore now, that repo will probably be there. Yeah, that's might be a useful way of sort of displaying that stuff. Or as I say, there's these visual tools that you can use these days, like SourceTree and GitHub Desktop and stuff, if all this command line stuff is just too complicated. It can be sometimes easier to just see them all in there and have like lots of buttons that you can click. That works too.
Excellent. That was really interesting. Thank you.
Yeah, one more. Well, if you want, yeah.
When you're going to do that, you said I will clone this,
Yeah.
this and that, but before we're talking about forking when you wanted to work on your own version. Are they two
Yeah.
different things? Or are they
So forking is a GitHub term rather than a Git term. Forking basically just creates a copy of another person's GitHub project, another person's GitHub repo, creates a copy of it, but records the fact that it was based on a particular point in another repo, if that makes sense.
So it's really a fork of type of branch?
No, because it's the level above a branch. A fork contains lots of branches, because it's like a copy of the whole state of a whole, it's an entire repo. It's almost like you taking that directory on your computer and saying cp to here. Like that's basically what GitHub is doing.
So you're not forking a particular branch of
No, you're just copying the entire repo. That's what a fork is. And as I say, it's a GitHub thing, not a Git thing.
And when you clone?
Cloning is a Git thing, and that is making, you give it a path or a URL or an SSH address or whatever to a repo somewhere, and you're saying check out, like make a, another example of checkout being an overloaded term, like I want to make a local version of that repo here.
And once you have the local version, does it still keep track of where it came from?
Yes.
And at which commit, and you
Yes.
can kind of use that to
Yes.
do your pull requests? And
So it remembers, and all of that is what's stored in that .git. This one is, in fact, I can .git, let's edit that directory. So where is it? Is it an index? No, I can't remember where it's all. Config. There we go. So this is what's like. You never need to look at this, but basically this is where it's storing that information. So it's storing the fact that this was cloned from. It doesn't actually know that I created the repo on this computer and I pushed to GitHub first. Doesn't really make a difference.
Is it functionally, in terms of what you can do with it, kind of functionally equivalent to forking on GitHub?
Yeah.
Okay.
Yeah, effectively that's kind of what they're doing, I guess, on the back end. They're like doing their own clone sort of thing. I don't know how GitHub actually stores all this information.
When you fork, you create your own fork.
Yeah.
So when you make changes in the commit,
Yeah,
they go back to your fork.
your fork, yeah.
Whereas if you clone a repository, any changes you commit go back to the original repository.
Yeah, if you've got permission to write to that, yeah, you might not. You probably wouldn't, unless you're like on GitHub. Say, if you're part of that organisation, then you'd have that GitHub organisation. You're a contributor. You'd be able to push. Yeah, but if it's on your own server, then as long as you've got, if it's SSH that it's all working over, then as long as you've got access to that directory in SSH, then you'd be able to push to it, I guess.
That's how clients give me access to their code.
Yeah.
If I start on a new project, they'll say, well, here's the repo. I clone the repo down.
Yeah.
And then now I've got all their code.
Yeah.
And then I'll usually create a branch off that from my own work, or they specify use this branch in the repo that I push to that one in particular, into that branch. And then maybe the merging or whatever.
Yeah, exactly. Just the same as us. We do all of that, but we do it just like internally inside our own organisation. Like the client never gets involved really in like the nitty-gritty of what's being merged and stuff. But we act sort of as our own client. So there'll be somebody who writes the code and there's someone who reviews it to make sure that mistakes don't get through.
Permissions to only one branch, or there is no permission system?
It depends on what you're using to host it. It depends.
Yeah.
Because like there's a lot of because you can use GitHub, you can use Bitbucket, you can use GitLab, you can use platform as a service solutions like platform.sh or Pantheon or something like that. And with those, you can give people certain permissions to only read and write from certain branches. So a client might want to give me access to a development branch, but not master.
Yeah.
But Git itself doesn't have built-in permission system.
No, I don't think it does. No. I'm trying to think whether GitHub does. I don't think it does it?
I don't know.
It has like protection so that you can say that in GitHub, like pull requests can't be merged until they've been approved by at least one maintainer. So lots of open source projects have that set.
I suppose the forking system covers that functionality in the sense that if you don't want people in your big shutdown, then they fork and
Yeah.
they send you pull requests.
Exactly. So that's what Matthew just did earlier. Like, I didn't add him as a contributor to my repo. He just forked it, submitted a pull request. So that way he hasn't got forevermore like write access to my repo.
So if you're using SSH to get to a private server, you would just use normal operating system access controls.
Yeah, I guess you would.
Decide who could write to which
Yeah.
directories.
And then that's what the Git system itself in some way does.
Yeah.
It's all Unix stuff anyway, isn't it?
Yeah.
And it
And
passes
the
through
Unix
all of
permissions or ACLs or something like that.
Yeah.
Yeah.
GitLab, by the way, does offer you the ability to use like individual branches as sort of repos in themselves, so you can do permissioning
Right.
on branches. I don't think GitHub does.
And it's open source itself as well.
Yeah, you can have your own.
GitLab, yeah.
Just got to mention.
Yeah.
It is
Yeah.
actually open source itself.
GitLab is really good, just as good, and yeah, Bitbucket too. I have a fondness for Bitbucket because it's what we used to use back in the mercurial days.
Private repos.
And exactly before GitHub basically has now eaten their dinner by providing everybody with 5, I think, private repos by default for free users, or is it unlimited on
It's
GitHub?
unlimited, but you can't have an unlimited amount of collaborators.
Ah, right, that's the difference.
But GitLab again offers everything basically.
Yeah.
Free.
Yeah.
Except for collaboration.
So yay for GitLab. You can also use that. The downside is that you haven't got the network effects of GitHub. Like lots of people have a GitHub account if they're software developers, so it's easier to collaborate theoretically. But it's also owned by Microsoft and it's proprietary.
Have
So
you seen how many repositories Microsoft's got? It's insane.
On GitHub.
Like 10,000 repositories.
probably. Cool. Thanks. Sorry that took ages, but
So
there you go.
That's fine. Yeah. Thanks very much.
No problem.
For your time and yeah.
Thank you.
Cool. I'm going to stop recording now for my hard disk.